Okay, so what we need to do is talk about proportional reasoning and using Newton's law of universal gravitation. Since that's a massive mouthful, we'll look at it by simply talking about my cats and gravity for a little bit. So, I have two cats. One is Cinder. She's black, she's old, she's kind of a princess, and mostly she's super skinny and has a really long tail. And then I have another cat named Heidi. Heidi's gray, she's angry, she's got a lot of stripes, but mostly she's just super fat and has a little short tail. So, hey, remember this formula? Good old Newton's law of universal gravitation. Well, according to Newton's law of universal gravitation, my two cats here, they are attracted to each other by the force of gravity. Now, exactly how much? Well, let's do that math real quick. So here we've got Cinder and Heidi. So Cinder nowadays, she masses about 2 kilograms. Heidi, on the other hand, 5 or 6, so we'll just say 5. So, because my cats are using proper social distancing, they are 2 meters or 6 feet apart. So let's plug all of those numbers into the Newton's law of universal gravitation formula. That gives us the force of gravity is equal to big G, which is 6.67 times 10 to the negative 11th, times mass number 1, which is going to be 2 kilos, times mass number 2, which is going to be 5 kilos. All that divided by R, which is going to be our distance between the two down here, squared. So let me go ahead and plug that into a calculator. So 6.67 times 10 to the negative 11th times 2 times 5 divided by 2 squared. Push enter. So that is a pretty tiny number. So that gives us a force of gravity of 1.7 times 10 to the negative 10th. So that means our force of gravity is equal to 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 7. Oh, and these are newtons, by the way. So gravity, when you're dealing with newtons, unless you have a planet involved, it gives us some pretty ugly math. So instead, for our proportional reasoning, what we're going to introduce is the kerfluffle. The kerfluffle is a magical unit of force that makes the math easy. Now, we're going to start off here with back when Heidi and Cinder were both kittens. Well, at least smaller than they are now. So for our baseline, we're going to say that Cinder has a mass of 1 kilo, and Heidi has a mass of 1 kilo. So now, let's plug everything in using kerfluffles instead of newtons. So what we know is that the force of gravity is equal to big G. Now, big G in kerfluffles is 1. Okay, mass number 1 is 1. Mass number 2 is 1. And you look down here, our distance between the two is 1. So the force of attraction in kerfluffles between them for a baseline is 1, we'll call it little k. Okay, so that's a much easier number to deal with than that nonsense. So our baseline, if everything is the same and they are 1 meter apart, our force is 1 kerfluffle. So now let's look at things a little bit differently. Cinder over here still has a mass of 1 kilogram. Okay, whereas Heidi now is fat. she has doubled her weight. So that means her mass is 2 kilograms. Notice they are still 1 meter apart. So now let's plug these things in. So our force of gravity is equal to 1 times 2 divided by 1 squared. So that gives us a force of gravity of 2 kerfluffles. So you'll notice we doubled one mass, and that doubled our force of gravity. So let's see what happens when we switch those. Actually, no. Now, we're doubling both of them. So Cinder got fat too. So she's now 2 kilograms as well. And Heidi is still 2 kilograms. So you'll notice here our distance is still the same. Okay, because we're not messing with distance yet. So let's plug everything into the formula. Force of gravity is equal to 1 times 2 divided by 1 squared. So that means our force of gravity is equal to 4. So if we double both masses, our force of gravity is quadrupled. Okay? So this is something called a direct relationship. In a direct relationship, as one of the masses increases, the force of gravity increases the same amount. Okay? So if we look back at that, if we doubled one mass, we doubled the force of gravity. If we doubled both masses, then we quadrupled the force of gravity. Okay, so if you double masses, the force of gravity goes up in the same amount. Now, things are a little bit different with distance. So this time, Cinder and Heidi are both 1 kilogram again. They both went on a diet after that last question. So now, however, they are 2 meters apart. So that means when we plug everything into our formula, we have 1 times 1 times 1 divided by 2 squared. So that means our force of gravity is 1/4 of a kerfluffle. So that means that doubling R is 1/4 the force of gravity. Okay, so you double R, you get 1/4 the force of gravity. Let's see what happens if we actually move the two right next to each other. This time, their masses are still 1 kilogram. But this time, our distance is half of a meter. So our force of gravity is equal to 1 times 1 times 1 divided by 0.5 squared. Now, 1 times 1 times 1 divided by 0.5 squared is going to equal 4 kerfluffles, which means that if you half R gives us 4 times the force of gravity. What this is something called an inverse square relationship, which means as distance increases, the force of gravity comes down in a square pattern. So messing with your distance will have a much greater effect on the force of gravity than messing with your mass. So what happens if we mess with both of them? This time, what we've got Cinder still has a mass of 1 kilogram. And Heidi this time has a mass of 2 kilograms. And they are 2 meters apart. So that means our force of gravity is equal to 1 times 1 times 2 divided by 2 squared. Which means that our force of gravity is going to be 1/2 of a kerfluffle. Okay, so basically what happens is you sit there, you simplify it, and you can then use this ratio to calculate whatever numbers that you need to do. So go ahead and stay tuned for a few brief messages from me and my cats, even though they really don't want to be on the YouTube.